And this brings us to one of the LHC's biggest achievements, the discovery of the Higgs boson.
Ah, the Higgs boson, famously elusive particle.
Yeah, it's a big deal. The source describes it as being associated with the Higgs field, which is basically what gives certain particles their mass. And this Higgs field, it came into being right after the Big Bang.
So right at the beginning of the universe.
Imagine it like a cosmic syrup that fills all of space.
Cosmic syrup.
Yeah, bear with me. As particles move through this field, they interact with it. The stronger they interact, the more resistance they feel, and that resistance is what we experience as mass.
Oh, I see. So the Higgs field's like a drag on particles, and the more drag, the more massive they are.
Exactly. And finding the Higgs boson confirmed this idea. It was a huge validation of the Standard Model and gave us crucial insights into this fundamental part of the universe. And this is where the theories about CERN and reality shifts start to get really interesting, according to our source.
Okay, so we've unlocked this fundamental secret about mass. But the source brings up this interesting point about Stephen Hawking. He apparently said that the confirmation of the Higgs boson made physics less interesting.
Yeah, it's a famous quote from him. People interpret it in different ways.
Like he was disappointed or something.
Maybe a little tongue-in-cheek about how neat and tidy the discovery made things seem.
Oh, okay.
But the source points out something else. Hawking's Higgs boson doomsday theory, which he discussed in his lectures.
Higgs boson doomsday. That sounds pretty ominous. What is that exactly?
It's basically a theory about an instability within the Higgs field itself. The details are very complex, and it's all still theoretical. But the gist is that under extreme conditions, the Higgs field could shift into a lower energy state. And this shift could spread through the universe like a rapidly expanding bubble, and potentially, well, destroy everything.
So the thing that gives things mass could also lead to the undoing of, well, everything.
It's a pretty unsettling thought, yeah.
And the source connects this doomsday idea to the actual measured mass of the Higgs boson, which is 126 billion electron volts, right? They claim this puts the universe on the brink of instability.
That's the argument in the source, yeah. The idea is that this specific mass puts the Higgs field in a precarious position, like a balancing act.
Teetering on the edge.
Yeah, physicists call it a metastable state. And because so many particles get their mass from the Higgs field, if the field changes, even in one tiny spot, it could have a ripple effect throughout the entire universe.
And that could be catastrophic, I imagine.
Potentially, yes. So the source talks about this idea that, like matter, the Higgs field could exist in different energy states. And if enough energy gets concentrated, it could trigger a shift to a higher energy state. This would create this expanding bubble spreading at the speed of light.
And that bubble would change everything it touched.
Yeah, like a wave changing the properties of the entire ocean as it moves through it.
And if the energy goes past a certain point, I think the source mentioned a figure of 100 billion giga electron volts.
Yeah, that's the threshold, according to them.
That's when you get what they call catastrophic vacuum decay.
Right. And the end result. The end of our universe as we know it.
So we're talking about the complete annihilation of everything.
It's a pretty extreme scenario, but that's the idea. And here's where the concept of the multiverse comes back into play. Some physicists, the ones mentioned in our source, they've wondered, if this vacuum decay happens and our universe basically ends, where does all that energy and matter go?
It can't just disappear, right?
Well, that's the question. And one thought is that it might spill over into another universe. Remember, the idea is that these other universes might have different physics, different fundamental particles.
So our reality could merge with another one during this vacuum decay event.
That's one speculative possibility. Maybe a vacuum decay triggered by some incredibly high-energy event could destabilize the boundaries between universes, and then boom, our reality merges with another and we start experiencing these weird little inconsistencies, these Mandela effects.
So maybe we're seeing traces of another reality bleeding into ours.
It's a wild idea, but that's the suggestion. And our source even touches on string theory for a bit. You know, that idea that there are higher dimensions with all these bubble universes on their own membranes.
I've heard of string theory. Very complex stuff.
Yeah, it's incredibly complex. But our source uses it to suggest that maybe these bubble universes sometimes bump into each other or merge. And that could also explain the Mandela effects, these shifts in our reality.
Okay, so we've gone from misremembered cartoon bears to potentially universe-ending events caused by the most powerful machine ever built. I mean, could the LHC really be responsible for breaking our universe, as the source puts it?
Well, that's the central question they're exploring, isn't it? It's a whole chain of theoretical possibilities. the LHC influencing the Higgs field, leading to vacuum decay, and then the possibility of our universe merging with others, resulting in the Mandela effects.
It's a mind-blowing thought, but it's important to remember that this is all highly theoretical. As the source itself acknowledges, we're dealing with very complex ideas, and our understanding of the universe is constantly evolving. We're pushing the boundaries of quantum mechanics and cosmology here, where things can get pretty fuzzy between established science and speculative ideas.
Absolutely. It's important to keep that in mind. And we're really looking at one specific interpretation of these ideas here, connecting them to the Mandela effects, which are still a mystery.
It's definitely a thought-provoking look at some of the most fundamental questions about reality itself. And I think it raises even more questions than it answers. So, after hearing all this, think about it. Our universe might be this incredibly intricate system on a knife's edge, so to speak. And we humans, with our technology, are pushing the limits of what we know and what we can do.
It's definitely food for thought.
So what other unexpected consequences might our pursuit of knowledge have? It really makes you wonder, maybe this deep dive has sparked a curiosity in you. Maybe you'll go out and explore the world of quantum mechanics and cosmology a little further on your own.
Always good to keep asking questions.
Exactly.
And keep exploring.
Thanks for joining us on this deep dive. It's been a wild ride.
It has.
Until next time.
See you.